Hi everyone, welcome to one more video in the series of the Quant syllabus videos. Here we're going to talk about arithmetic for CAT 2025 aspirants. I'm Amit Panchmatia, National Chief Mentor at IMS. Now, if you've seen my earlier videos, you would have noticed I've already stressed upon the importance of arithmetic. Arithmetic would be approximately 40% in the whole Q8 section of the CAT, whether it is 24, 25, whatever, it will be approximately 40%. I don't see expect any drastic changes in this year suddenly. Okay. So obviously the first point, it is the most important area for all CAT aspirants and especially for the Q&A sections. Weightage approximately in the last 5 years is 40%. Last year, in the previous video, we've already spoken about what module has how much weightage and all that. So you can have a look at that video if you want. In this video, we will talk more about detail in arithmetic. We will get into each chapter, what kind of concepts are required for each chapter, how difficult, easy is it, what kind of questions are asked, and so on. Now, one other important reason I always stress so much on arithmetic is it has the maximum level A questions. So for example, when I say 40% of 22, roughly 8-9 questions are there from arithmetic. But out of those 8-9, you would say at least 4 or around that would be 4 to 5 will be level A questions and hardly any level C questions. Now compare that to some other topic like numbers or geometry or algebra, in fact, where the weightage is pretty high. So algebra weightage would be say 25-30%. But the number of level A questions are much lesser over there. And that is why I think arithmetic is one area you should always concentrate on. And obviously, the other reason is it creates a base for solving DI faster. A lot of people after the calculator has come in CAT don't pay attention so much to calculations of percentages and so much, how to do it quickly. Finally, you'll understand on the day of the CAT that actually using the calculator is a lot more time consuming than what you actually had thought. So if you know your basic calculations well, that will also help, and that you can do through arithmetic. Now, let's look at the topics in arithmetic. And again, number of questions in the last 5 years. This is mainly the last 5 to 6 years. 160 questions were asked in arithmetic, and these are the breakup of that. So percentage approximately 19 questions, ratio, proportion, variation 16 questions. So the first two areas are pretty similar. A lot of people keep saying that direct questions are not asked from these topics. But even if direct questions are not asked, if you look at the next two topics, 16 and 14, profit and loss and SICI, are actually so directly connected to percentage. If you know percentage well, you will know these two topics also well. Allegation mixtures are means and weighted averages, which at IMS is anyway is a single chapter, will have a weightage of 40 questions. That's like huge. No allegations, mixtures, means, weighted averages, maybe a little bit of mean, median, mode. All those things together will give you 40 questions. That's like huge. So please see that part of the arithmetic is done really well. Then there is work, pipe and systems, 21 questions. I think a very, very scoring area, very easy area. And time, speed, distance, some people love it, some people hate it. It has a good weightage, 34 questions. So I would suggest that you fall into the category who start loving it rather than hating it. So as I said, 160 questions from arithmetic. Now let's look at each area. Let's look at each chapter, and let's look at within the chapter what concepts should you know. Okay, so first, when I talk about percentages, let's talk only about percentages. So obviously you will need to learn introduction to percentages. When I mean introduction to percentages, you need to know, when I talk about percentages, you need to know how to convert percentage to fractions, how to convert fractions to percentage. If a particular number is so much out of say 250, say 30 out of 250, what percent does it mean? That's nothing but converting a fraction to a percentage, 30 divided by 250. So how do you convert that to a percentage, and how is the percentage converted to a fraction, and so on. Then there is percentage offset. What is percentage offset? Percentage offset means that if the price of a product increases, how much lesser quantity will you have to buy so that your total expenses remain same? That's offset. So most common example is if price of petrol goes up say by 10%, by how much should you reduce your consumption so that your total expenses is constant. Then there is successive percentage change. Suppose the salary of a person increases by 20% and then again increases by 10%. What is the net change? The net change is never 30%. The net change will be 32%. Understanding that concept well with different approaches is important. Moving on to ratios. Obviously, again, introduction to ratios, how to understand what is a ratio, why do you write a ratio, how do you write a ratio? What does a ratio mean? So if I say A upon B is 5 upon 4, what does that mean? Does it mean that A is 5 and B is 4? No, it doesn't mean A is 5 and B is 4, but it can mean A is 5 and B is 4. Or in short, if A was 5, then B would be 4. All that will help you introduce ratios. If you add something to a ratio, numerator and denominator both, what will happen? Will it increase? Will it decrease? And so on. Same way, introduction to proportion. If A upon B is equal to C upon D, that's proportion. If A upon B is equal to B upon C, that's continued proportion, and so on. Later helps you later in geometric progression also. Then there is variation, direct and inverse variation. What is direct and inverse variation? Basically, if A increases, then B also increases. Or if A varies as B square, then if A increases, then B square increases, and so on. That is direct variation, right? So in, say, if 10 kgs of sugar cost 100 rupees, so 20 kgs will cost more. That is direct variation. And then there is inverse variation, which helps a lot in time, speed, distance also. Both the variations help a lot in time, speed, distance. So for example, if you increase your speed to go to a particular place, if you go traveling from Mumbai to Pune, and if you increase your speed, what will happen? Your time taken will be less. That is inverse variation. So all those things will help. And then there is a topic of partnership, which comes a lot in ratio proportion, which can be solved through ratio proportion. Let's move on to SICI, simple interest, compound interest, knowing interest. This is, a topic which all MBA aspirants should know really well, especially the ones who are going to look towards finance in the future. You should know how to calculate interest of all different types really well. Introduction to interest, simple interest, compound interest. What is the difference? Why are there two types of interest? What does compound interest mean? It means interest on interest. What does it exactly mean? Difference between compound interest and simple interest for 2 years, 3 years, all those properties, formulas. Right, that's the second one. Different time periods of compounding. So basically, some banks compound interest at the end of 1 year, some compound at the end of 6 months, some at the end of 1 month, and so on. That's different time periods of compounding. Then application of compound interest. There will be population increase, depreciation. Such questions will be application of compound interest. And then there will be installments. So installments will be the EMIs. The whole world is getting so used to buying everything on EMI. If you actually understand it, what does it mean? It will really be helpful. Concepts in mean, weighted averages and mixtures. Behavior of averages. What happens to an average? When a new person adds into your group, suppose you have a group of friends, one more new friend comes into that group, maybe who's slightly older than all of you all. What happens to the average age? The average age might go up. Same way, when does the average age go down? Think of cricket. Kohli is having a particular average. After a bad series, what happens to his average? His average will go down, but by how much? All those things becomes behavior of averages. Then there is mean, median, mode. A lot of people concentrate on only one average, mean. We always think of average only as mean, but average also can mean median, average can also mean mode, and so on. Then there is geometric mean, arithmetic mean, geometric mean, and harmonic mean. This will be an important area. You should know that, because these have all three applications later in other topics also. Weighted average and allegation. So allegation is nothing but a particular way of solving weighted average. So a lot of people keep thinking, what is allegations? As I said, allegation is nothing but just a way of solving weighted average. What is weighted average? Basically, if there is a different weightage to two things, there's a weightage of 2:1. Say in your college exams, maths and physics, suppose have a weightage of 2:1. So if you get, say, 70 in maths and 80 in physics, is your average 75? No. The weightage will be different. 70 multiplied by 2 plus 80 multiplied by 1 divided by 3. That's weighted average, and so on. Mixtures, addition, replacement, percentage replacement. There is a mixture of milk and water. What happens if you remove some mixture and replace it with only water? It will dilute further, percentage will go down. That is addition. There is only addition, there is replacement, and then there is percentage replacement. Wine-left formula is an important part of mixtures. It's just a particular concept. So, we normally talk about this concept very alone, so that people understand this concept well. The wine-left formula. Concepts in time and work. Introduction to time and work. That is, you need to know what happens in time and work questions, what happens in this chapter. Efficiency and time taken to do some work. Basically, if A can do a work in 10 days, B can do a work in 20 days. What is their efficiency? Okay. And how quickly can they finish the work together. So understanding the LCM approach over here is very, very important, because school days you will learn everything through fractions over here. Over here, we would want you to know the LCM approach and do that very carefully. Then there's, based on that, there's a concept of man days. If so many men can finish a work in 100 days, if say 10 men can finish a work in 100 days, what does it actually mean? It means that the whole work is 100,000 man days, and so on. Then there is similar with, that is pipes and cisterns. Basically, the concept is same, but just if so many pipes are on, they can fill the tank in so much time. What happens if there's a leakage? All those concepts are important over here. Concepts in time, speed, distance, one of the biggest chapters, in fact, at IMS also, we've divided this into 2 or 3 chapters, and one of the biggest chapters, introduction to time, speed, distance, knowing what is the relation between time, speed, distance, when there is direct variation, when there is inverse variation, all those things are important. Then there is average speed, because you don't consistently travel at one speed. If you travel for the first hour at so much speed, second hour at so much speed, what was your average speed? Relative speed, problems on trains. 2 trains are moving. Does it mean that if one is moving at 60 and the other is moving at 70, and in the same direction, the relative speed will be what? If they are moving in opposite direction, what is the relative speed? Problems on trains. Then there is boats and stream, which you've been doing from school days. Similar to that is escalators. Very similar to boats and stream is escalators. And then there is linear and circular races. So races concept is very, very different. You need to really understand the concept of especially circular races to understand it well. And then there will be mixtures. Geometry with time, speed, distance is very, very important area. Maybe some of these concepts might come after geometry, but the geometry with time, speed, distance is important. And then there is clocks, which, because a clock is nothing but 2 people running in a circular race. As good as that. The concept is very similar. So learning clocks with time, speed, distance makes a lot of sense. So that is it, what we cover in this video. We are going to, as I said, we covered all the chapters of arithmetic, the importance of these chapters, the concept within the chapters. So please go through each thing very carefully, understand where you want to revise the concept from. If you're an IMS student, you have all the concept videos available for these concepts which I spoke about. Otherwise, you can look at it from some book or whatever else you want to look at. That's okay. But you just need to understand each of these things. I've covered most of the things. And as usual, if you feel I have missed out something, you can always add it in the comments. I'll add some value there.